Hello students, and welcome to section 4-5, Proving Triangles Congruent, ASA and AAS, which stands for angle side angle and angle angle side. The angle side angle postulate, or ASA, lets you show that two triangles are congruent. So ASA postulate: if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. We're going to start off with a two-column proof. I did have to make some adjustments here, so please be mindful of that. The given is that AB is parallel to CD, which you see in the picture. Angle CAD is congruent to angle ACB, which I am going to mark here. So CAD is congruent to ACB. Okay. And I'm going to go ahead and add two other components here that we know are true but aren't particularly given. We know that AC is congruent to itself. We also know that this angle is congruent to that angle. Now, why would I go through that process now before I go through the actual proof? Well, remember, our goal is to use angle, side, angle in context to prove that these two triangles are congruent. Angle, side, angle on one triangle, angle, side, angle on the other. So let's go ahead and lay out the proof, see what's been done here. So the first two steps you can see are given. AB is parallel to CD. Angle CAD is congruent to angle ACB. Okay, remember again, those are the red marked angles that, thanks to the given, we marked as such. Okay. The third step is angle ACD is congruent to angle CAB. And that's true, as we can see marking the double angles there in blue, thanks to the idea of because lines are parallel, alternate interior angles are congruent. That's the alternate interior angles theorem. The fourth step is that AC is congruent to itself, which again we've also marked as such. It is the reflexive property of congruence that makes that true. And then last but not least, if we take a look at all the components together, we have angle, we have side, and we have angle. And it's obviously not in the order that necessarily speaks to the final answer when you write your letters, but ASA, given the fact that the side is included. So the included side here is what we want to make sure, in fact, is in the middle of our depiction of both triangles. Let's move on. Exercises. So I'm going to go ahead and take a look at one of these two proofs. I do encourage you to take a look at the second one on your own. We'll go ahead and take a look at the next page, and we'll also go ahead and take a look at maybe some extra problems that are non-proof based to give you some practice that way. So write a two-column proof. You can see here in the picture we've got ourselves two triangles that happen to share, and I would mark this now, they happen to share point T. Now point T should help us understand also, as I noted just now, the marking there, that those two angles are in fact congruent because they're vertical. Anytime you have parts that are congruent, you might as well mark them as soon as you can before you actually start doing the proof. It's a good practice to get ahead of the game, so to speak. We know in the given that angle S is congruent to angle V, so mark it up accordingly. And we also know, according to the given, that T is the midpoint of SV. What does that mean? Well, that means that this side is congruent to that side, right? ST, therefore, is congruent to VT. Now, I would argue just by virtue of the picture, you can already sort of see here angle, side angle, angle, side angle. Okay, mark that a little bit heavier. So those are your included sides that you see in between both respective angles. Our goal is to prove that triangle RTS is congruent to UTV. So let's go ahead and take a look. First step, given angle S is congruent to angle V, and T is the midpoint of SV. Second step, ST is equal to TV, definition of the midpoint, And angle RTS, as we've marked in red, is congruent to angle VTU. Those are vertical angles. If we continue, we can argue that for sure now we've got all that we need with respect to what? We've got angle, side angle, angle, side angle. So triangle RTS is in fact congruent to triangle UTV, and that's by ASA, or angle, side angle. A couple of extra little corrections, so to speak. I do believe the book intended to have these as segments congruent, so I'll add that nuance. And then as far as the ordering of the letters, they said RTS, and then they said VTU. I would actually argue for UTV. It's a subtle correction there at the very end, only because, well, if you notice that technically angle R is congruent to angle U in the picture, and S is congruent to V. So I'm going to rearrange those. So the second triangle there is U, TV, therefore angle U, TV. On the next page, let's take a look. This is angle, angle, side. This is actually something that, as they're describing here, something that we're going to go ahead and utilize in various ways later as well. We're going to look at flow proofs as well as paragraph proofs. Angle, angle, side. Another way to show that two triangles are congruent is the angle, angle, side theorem. Here's how it reads. So angle, angle, side theorem. If two angles and a non-included side of one triangle are congruent to the corresponding two angles and side of a second triangle, then the two angles or triangles, are congruent. So we're talking about a non-included side. So quite literally, that second letter, as you see here, is an angle, not a side, so it's not between the other two parts. So we now have 5 ways to show that two triangles are congruent. We have the definition of triangle congruence, side, 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 angle, side, and now angle, side, angle, and angle, angle, side. So let's take a look. In the diagram, angle BCA is congruent to DCA. Which sides are congruent? Which additional pair of corresponding parts needs to be congruent for the triangles to be congruent by the angle, angle, side theorem? So as we can see, just by virtue again of how the side AC is shared, I'm going to go ahead and mark it up as such. So AC is congruent to itself. And the reason, again, we can say this, if you recall, AC is congruent to AC, is by the reflexive property of congruence. It's shared by the two triangles. The congruent angles cannot be angle 1 and 2 because AC would be the included side. Now again, we should also note, based upon the picture, that we do have an angle and we have a side. If we wanted angle, angle, side, we would need not this angle, because that would be angle, side, angle, and on the other triangle, angle, side, angle. So angle 1 and angle 2 are not going to be what we want, AC again being in between. We would have to argue that angle B is congruent to angle D. So the third part to prove angle, angle, side would have to be this. If angle B is congruent to angle D, and yes, we can use a single letter here because it's a single angle, then you could argue that yes, the triangles are congruent by angle, angle, side. So here it is. Angle, angle, side, angle, angle, side. Typically we like to go in order, so angle B, angle, and then this angle here, BCA, congruent to angle D respectively, and then that angle, D, and then DCA, and then lastly the side again. So angle, angle, side in order, angle, angle, side. We like to leave off in our final statement with side. Okay, so I'm going to finish here on this particular page with the flow proof at the very bottom. I did discuss that flow proofs, but also paragraph proofs were going to be something we take a look at more in depth. So this flow proof, as you can see, it says given angle S is congruent to angle U, and it is marked for you, TR bisects STU, that means angle STR here is congruent to UTR, and they've marked it as well for you. I'm going to add a marking, and I need you all to do the same now, and that is that RT is congruent to itself. And just by looking at the picture, angle, angle, side, angle, angle, side. So we know where we're headed. The last part, hopefully you can all see here, it says angle SRT is congruent to angle URT. So that's going to be a final step that after we prove triangles congruent, we'll be able to make that assessment. Here's how the flow proofs work. Very similar. Okay, so you're going to start with your given. Okay, TR bisects angle STU, and that leads to the following. Okay, angle STR is congruent to angle UTR. That is by definition of angle bisector. So again, STR congruent to UTR. Angle S is congruent to angle U that was given. And then you also see here as the kind of third part of the second process, you've got RT congruent to itself, and that's by the reflexive property. So these three things that stem from this, the given, leading to this, and these two included with this part here, lead to what? That triangle SRT, so SRT is congruent to triangle URT, and that's by angle, angle, side. Now remember, the question wasn't asking you for congruency of triangles, it was asking you for congruency of angles. So after you prove that the triangles are congruent by angle, angle, side, you can finalize your answer as you see using CPCTC as your reason. So angle SRT is congruent to angle URT. Quite literally, corresponding parts of now congruent triangles are congruent. So again, once you've proven the triangles are congruent, every corresponding part is congruent. So again, angle SRT here is congruent to angle URT there. As our extra practice, similar to the last section we worked through, our extra practice will detail, and I will be going through more of this in class tomorrow. But extra practice, as we've seen with section 4-4, I pulled this in from another textbook again. I'm going to go ahead and just help you guys with regards to, again, angle, side, angle, and angle, angle, side in context without necessarily doing proof. So let's just take a look. I think number one is a good problem to detail. It shows here that you've got two triangles. Here's one triangle. Here's another triangle. You are to determine whether each pair of triangles is congruent, and if so, write a congruent statement and explain why the triangles are congruent. If it is not possible to prove that they are congruent, write not possible. So right off the bat, you can see that it's marked as such. Angle GIH is congruent to angle JIK. I've marked it with the double angle markings, or these double markings. And as it turns out, they gave you that angle G is congruent to angle J, and they gave you that side GH is congruent to side JK. And let me go ahead and therefore off to the right note what I indicated. As you can see, angle G is congruent to angle J, that's an angle. Angle GIH here is congruent to angle JIK there, obviously angle again. And then lastly, GH, this side is congruent to JK, that side, so that's S. And of course, I'll go in order, angle, angle, side, noting the side is not in between, so it's not included. And then on this picture, or this triangle, angle, angle, side. They're all marked, as you can see, as such. So these are marked the same, those are marked the same, and then the sides, of course. So this is certainly an angle, angle, side congruency. In the end, our statement looks like this. Triangle GIH, in order, GIH, is congruent to triangle JIK. And again, that's by angle, angle, side. Please take a look at those other completed problems. They're a great guide for you to understand angle, side, angle, and angle, angle, side. We will continue this, of course, tomorrow.